All right, so 10.4, number 1. So we're talking about hyperbolas. Actually, before we dive into number 1, let me just give you the setup. So 10.4, hyperbolas. Hyperbolas. What are they? Well, they're basically, let me give 2 examples. They're 2 branches faced away from each other, like this, or up and down. So they're right and left, or they're up and down. How so? They look almost like the ellipse equations. Very, very similar. That is so similar to the ellipse. What's the only difference between that and the equations we were just doing? Minus in the middle instead of plus. That's it. It's super similar. Now this one's going to have y squared in the front. See how similar it is? Very, very similar to this. They just have a minus in the middle instead of a plus. What that minus does, the way I remember it, is it makes the branches turn away from each other. They have a negative relationship. So there's my little way to remember it all. So I just say, okay, look, if there's only one letter squared, it's a parabola. You remember that? Remember how the parabolas only had like y squared, but x was not? Or x squared, but y was not? Remember that? Those were parabolas, remember? That's why they only had one branch, either going left, or going right, or going up, or going down. They only had one branch. They didn't have 2, because they only had one letter squared. So here's the way I remember the big picture. So, parabolas. So let me just write it out for you. Come on. Parabolas. They only have one letter squared, like y squared is 4ax. That would go to the right. Remember, positive x? They only have one letter squared. Ellipses have both letters squared, so they have both branches, and they have a positive relationship. So it's like the 2 branches are positive. They're connected together. Hyperbolas now, same thing, but they have a minus in the middle, so it's like they have this negative relationship. They have turned away from one another sideways like that. So there's my little memory device, if that helps you. So ellipses and hyperbolas are both got the 2 branches. Positive, they connect. Negative, they turn away. And parabola only has one branch. Now, if there's 2 ways hyperbolas can go, though. If x is in the front, then the things are on the x-axis. If y is in the front for the hyperbolas, if it's y in the front, then the branches are on the y-axis. They're turned away up and down instead of right and left. Does that make sense? Y in the front, up, down. X in the front, right, left. For the hyperbola branches. So it's whichever letter's in the front. Whichever letter's in the front. That's different than the ellipse. For the ellipse, it mattered which one had a bigger number underneath, x or y, didn't it? For which direction was the bigger. It doesn't matter for the hyperbola. The other one could actually have the bigger number. Who cares? It's who's in front. For the hyperbola, it's who's in front. If x is in front, x squared's in the front, it's going to be right and left. If y squared's in the front, it's going to be up, down. Question?
So that's why it doesn't matter if A or B is under
Yeah.
Y, because when you're adding each other.
Well, the A and the B will still play an important role, and they'll still be almost the same thing they were before.
In ellipses, because you're adding, it doesn't matter where you put A or B is at.
No, it does matter actually where A and B are because of the focus equation. It's actually because of the focus equation that it actually matters. Yeah, I'll explain more of that. Okay, so with that big picture idea, let's go back to problem number 1. Say, okay, look at... yeah, we're going to be able to do this one? Yeah, let me show you one other thing. Yeah, I'm just going to do some freelance work, and then we'll go back to number 1. So let me just make one up. I think that'll be easiest for you. So what if I said x squared over 4 minus y squared over 9 equals 1? I'm just going to make one up. I wish they'd started you this way. Let's just make a simple one up and just go from there. All right, so how would you, it's going to be how do we know it's a hyperbola? 2 branches turned away instead of an ellipse, one big H shape. How do you know that? Minus in the middle. minus in the middle, negative in the middle, minus in the middle, it's going to be hyperbola. They're turned away, they're unhappy, negative relationship. Okay, so anyway, how do you graph the thing? Pretty much the same as ellipse. That's what's nice about this section. This will be the easiest of the three. It's not a lot different. You pretend that said plus for a minute. Just pretend with me. What would you do first? Where would the center be? 0, 0, because there's nothing next to x or y. It's the same thing for hyperbola. Okay. What would I do with that 4? That's 2 squared. This one's 3 squared, really, right? So what would you do? Whatever's underneath x is right, left. So I'd go right 2, left 2. Put a dot, put a dot. There's the edges. What would you do with the 3 squared? Up 3. Put a dot, down 3, put a dot. And then I would just make a big egg shape, right? Well, that's all the same for the hyperbola, except when you get to this point, don't make an egg, obviously. It's not an egg shape. Instead, make a dotted box. So you all with me? I'm showing you how you actually make it. Now, remember, whenever we're doing a dotted thing on any graph, like an asymptote line or any other part that's dotted, it means it's not really part of the picture. It's just a guideline. It's just there to help the graph or hold the graph or guide the graph, but it's not really part of the actual set of points that make the graph. You see how they use dotted things on graphs? It's just to help. It's just to hold the graph, but it's not actually part of the graph. It's not one of the branches. So instead, I start off just the same. See how I'm doing it just the same? As if it was an ellipse. Right? In fact, let me change it back to the fact that it's actually minus in the middle. It is a hyperbola. But I'm doing the same thing. I just went right 2, left 2, up 3, down 3, put my dots. Same thing I would do if I was making an egg shape. Except instead of making an egg shape, I make a dotted box at up 3, down 3, right 2, left 2. And now, why the dotted box? What I really want is the diagonals. Now go corner to corner through the middle with more dots and shoot out the edges. These are going to be asymptote lines. They're going to hold the branches. They're going to tell you how wide to make the branches. That's why you need the box. The shape of the box determines the angle, right, the slope of these asymptote lines, which will guide the branches. You tracking with me? So, I started off just like an ellipse. I went right 2, left 2, up 3, down 3. Right? Underneath x, right, left, y, up, down. Put my 4 dots, but instead of making an egg, I made a dotted box, and I filled in the diagonals and let them shoot out the edges. Those are going to be asymptote lines. Now, the branches, now we're ready to draw the graph. The branches go on the edges of the box, either right, left, or up, down, depending on whatever's in the front. I've got x, so my branches are going to be right and left. It doesn't matter that that's the smaller number. Doesn't matter for a hyperbola. It's just whoever's in the front. So who's in the front? X. That means I go right here and go branch. And see how it gets closer to those asymptote lines forever? Branch, and I'm done. That makes sense? So it's very similar to ellipse. Instead of making an egg, make a dotted box, fill in the diagonals. Branches right and left if x is in the front. If those were swapped and y was in the front, the branches would go up, down, starting in the middle of the body. They always hit the middle of the box, those dots that I originally put down. It does go through that dot. I kind of missed it a little bit, but it does hit this dot. It does hit this dot. If it was up, down, then it would hit the top dot and the bottom dot. Now, there are focus points. Where are the focus points in all these graphs? Where are they? Are they on the graph? Never. They're always inside. So it's got to be like here and like here. And it is. That's always the case, right? They're always inside the shapes we're looking at. So the focus points are there and there. How do you find the exact location of those focus points? You use a focus equation. Guess what the focus equation is for the hyperbola. Now hold on. I bet you can guess. It's going to be the same thing as the other one, but the sign's going to change. Everything's the same as the equations we use for the ellipse, but the signs are opposite. So what was the focus equation sign for ellipse? It was a squared minus b squared. So what's it going to be for hyperbola? Plus. It's going to be the literal Pythagorean theorem, the exact Pythagorean theorem. So the way to remember this, well, I would put it on my 3x5 card for sure. But one easy way to remember it, whatever for ellipse and hyperbola, whatever sign you have in the original equation, you have the opposite in the focus equation. See what I'm saying there? If you have minus in the original, that means plus in the focus. For the ellipses, we had plus in the original and minus in the focus, didn't we? So that'll work. It's always the opposite sign in the focus equation. And this is the same thing. A and B, like I told you, it'd be the same. A and B are how far to the edges, and C is how far to the focus point. Same as. So C would just be how far to that focus point, and you could figure it out. Oh, and by the way, this one's easier to use than the other one. Why? Because they're added. So who cares what the order is? Remember all that careful thinking we did about which one's the bigger, which one's the smaller? Just forget it with the hyperbola. It's easy. Who cares? They're added. So what, like if I wanted to find C right now, let me go and find C. I would just put down 4 squared and 9 squared. No, that would actually be wrong. Don't do that. It would be 2 squared and 3 squared. Or you can make a 4 and 9. But don't square 4 and square 9 like I was doing. So that way, C squared. Now what if I switched them? What if I made it 3 squared plus 2 squared? Who cares? They're added. That's why we don't have to sweat it so much. Doesn't matter. Like, we don't have to be as careful as we were with the other one. So 4 plus 9 is C squared. 13 is C squared. Root it, plus or minus root 13. So this is plus root 13. This is minus root 13 to the focus points. We're done. We found everything. Get the idea? So it's not a lot different from ellipse. It's almost the same thing. 4 dots, right, left, up, down. Make a box with the diagonals. Diagonals are asymptote lines for the branches. Focus equation has the opposite sign of the original. All right, with that in mind, let's go now to do the questions. So now we're ready for number 1. They're giving me a picture. The branches are going where? Right, left, or up, down? Right, left? So who's in the front then? X. So no way on A, they have Y in the front. No way on C, they have Y in the front. It's either B or D. So far, so good? It's either B or D. How do you know which one? Well, I personally, I would have to draw a little bit. Like, let me see if it's B. Let me start with B. If it was B, what? So let me just take B up here for a minute. It would be x squared. That's an understood 1, isn't it? Minus. It's all going to be about the branches and how wide they are. You can tell we have very tall branches. So everybody good so far? I'm just taking a guess. Maybe it's B. Let me graph B, and if it's not, the answer must be D. So see what I did for B. I gave it the look. There was nothing underneath x. You've got to have a number, so that's 1 squared. 3 squared, right? You've got to give it the look. We're always doing that. Okay, what does that mean? That means right and left 1, so 1, 1. Up and down 3. 1, 2, 3. 1, 2, 3. Already, I can tell this means taller branches, doesn't it? See how the branches are going to be tall? Because it went up. Whoops, I blew that. Anyway, it's going to be tall branches. Is that right? Yeah. That's what we have. That's right. See, if you did D, D would be wrong. Why? Because what's under there is 1 squared. So you'd only go up 1, down 1. You'd go right 3, left 3. You'd have a box that's very short and wide. You'd have branches that shoot out like this. Very thin branches, wouldn't you? Do you see that? So it's B. Did I do that too quick?
If the center is 0, 0, wouldn't you just know that you only went over 1 and 1?
I did.
Yeah, so would you still have to work it out like that? I mean, can't you already know if that one has a 9 underneath it, that it's not going to be that?
How'd you know? Why?
Because you only go, because the center of your branches are only at 1 and 1.
Oh,
1.
Good point.
Is it always gonna
Carissa,
be
you're
like that?
totally right, and I was just missing it.
Is it going to?
I worked too hard on that one. You're totally right. I did too much work. Look, this is over 1. I didn't even think about that. Yeah, Chris is totally right. That one's just over 1. So 1 has got to be underneath X. Boom. I didn't need to work so hard.
You always
Well, they're going to change up everything.
Yeah.
So, but yeah, if they give you a picture like that, yeah, just look at that. You're right. I didn't think about that. Yeah, it's just right 1. That's where the branch hits. So yeah, it had to be B. I didn't need to work so hard. Good point. Okay. So here we go. So they're giving me a couple focus points and a vertex. And they're saying find the equation. So you know what we're going to do? We're going to graph it because that always helps us with the equation. So let's start with a graph. And so they're telling me one focus is back 25. I'm just going to put a dot. Back 25, 0. And over 25, 0. And vertex point is 24, 0. So that means the vertex point is not quite so far over. So this is vertex, and this is focus and focus. Okay. Good so far? So can we generally, from that information alone, do we know enough to know generally what the thing looks like? Are the branches going right, left, or up, down? Right, left. They got to hit the vertex. The focus points are always, again, on the major axis. Same thing as we're used to. So, and they always hit the vertex. They don't hit the focus. Remember, focus are always inside, huh? So there must be another vertex here, and it must be like that, huh? Good? So far, how that's got to be, right? Focus points are always inside. They're not on the edge. Ever, for any of these shapes, right? Okay, good so far. And they're always on the major axis. The focus are always on the and we don't call it major axis. We have a new name. I don't know why they change the names all the time, but they call this the transverse axis. Trans, what does trans always mean in front of a word? Transportation. It means across. So they're saying which line cuts across, cuts through the branches, the x-axis. That's why I said right here, the x-axis is the transverse axis, the main axis, in other words. It's their word for main axis. You can just say main axis. It's the main. It's like major axis was for ellipse. So it's the main axis. So it's right, left, x-axis. So branches go right, left is x, up, down is y. I think it's a little natural. You won't have trouble with that. Okay, let's write the equation. With our last 3 minutes, can we write the equation of that one? Is it going to be x in the front or y in the front? Think about that first off. So write the equation. Is it? It's going to be a minus in the middle because it's a hyperbola. So is it that way or does it have the y in the front? X in the front because it's right left, huh? Branches are right left, so that's correct. It's got x in the front. Now what are A, B? Or A, B again there. How far to the edge? Like always, aren't they? How far to the edge? From the center to the edge. Same thing as the ellipse. A, B, and C. A and B are how far to the edge. C is how far to the focus point. Same thing. So how far from the center to the edge? Well, 24, huh? That 24, is that right, left, or up, down? Well, it's right. So it's right here. 24 squared. It's under x. X is right, left. Again, don't get hung up with A and B. They're interchangeable. Just remember, right, left, you're under x. Whether you call it A or B or whatever. Right, left is under x. Well, how do I find the B then? I don't know how far up and down. There's nothing up and down. There's an invisible dotted box, but I don't see that. How am I going to find the B? Focus equation. We know C. What's C? From the center, remember. All these things are from the center. A and B are from the center to the edge. C is from the center to the focus point. So what's C? 25. It's the 25, right? It's not 1. It's 25, right? From here to the focus point is 25. That's C. And this was A. Right? C is from center. In all the shapes we deal with, well, ellipse and hyperbola. C is from the center to the focus point. So if you use the focus equation, a squared, and we use plus, right? For the hyperbola, whatever sign in the main equation, it's opposite in the focus equation. So that means what? 24 squared plus b squared is 25 squared. Is that 476 plus b squared is 5? Oh, 576. Thank you. Oh, wait a minute. Did I do that right then? No, 6. Is that 625?
It's 625.
I'm having all kinds of troubles. All right. So then solve that. Minus 576. And 24. Was it 49? Oh, okay. So B is 7. 7 squared. We're done. Is that good? Does that make sense? All right. So we got started.